Not bad. How are you, sir? No, I was just I was just wondering if you could test my audio and picture. Ben asked me to do it, but the call drops every time I talk to him. Okay, well, mic check. Mic check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can you see me yet? Oh, I suppose it's probably on the PowerPoint, so you're probably not going to see me. Let me go look at the program. I don't know what I'm sending you. Our phone call, huh? All right, I just want to run down and check lip sync. Yes, sir. Yeah. I'm less inclined to. I think SCI is much more versatile because HDMI would limit us to only taking an output from the. I think that the SD card recorder has an HDMI out, and so do the 160s. But I use the 370s for pretty much everything, and they don't have HDMI. I don't think. Yeah, but that robs me of a monitor where taking an SDI out does nothing, and plus the TriCaster can stream itself. It doesn't need a tear deck. Data video does not have HDMI out. Let me look at it. Nope, it just has DVI in. Oh, I guess it has HDMI monitor in. Yeah, well, I feel like the SDI is worth it. I feel like an HDMI one we just wouldn't get nearly as much use out of because nothing will output to it. I'm not even. I think this SD card recorder is HDMI out. Maybe it's only HDMI in. I have no idea. Yeah. Right. Well, and I don't want to throw on a bunch of adapters to get to HDMI either. I like the fact that I can just take the tear deck, throw it on top of a camera, just have a camera and the tear deck and go, and not have to hook up a lot of other stuff. Nope, that's it. Just let Ben know that I tried to call him. All right. Thank you. Bye. Check. Mic check. 1 2 1 2 3 4. Mic check. Microphone check. Mic check.
Okay, I think we'll get started. My name is Linda Snetzlar. I am the Associate Provost for Outreach and Engagement at the University of Iowa. And these Hawkeye Lunch and Learns are sponsored by the Provost's Office for Outreach and Engagement. And we are happy that all of you are here today. Want you to know that we have a brand new website, and if you look at your name tag, the address for that website will be on your name tag. If you want any information about the Hawkeye Lunch and Learns, you can go to that website. And there are also persons to contact listed there, so if you have any questions, that will be great. If you wouldn't mind silencing your cell phones, that helps a lot as the speaker is presenting. And I will move into a brief introduction for our speaker today. Dr. Anderson has been on the faculty of the Department of Neurology and the Neuroscience program at the University of Iowa Carver College of Medicine since 1997. And he's the director of the Neuropsychological Rehabilitation Laboratory. He's also a founding member of the University of Iowa Aging Mind and Brain Initiative. We have several initiatives at the University of Iowa, and that is one of them. He serves on the board of directors of the Brain Injury Alliance of Iowa, and his research is focused on the brain basis of human cognition and emotion. And the goal there is to get a better understanding of brain function, and he is particularly interested in looking at brain function over the lifespan and in neurologic disease. So with that, I will ask Dr. Anderson to come up. Thank you.
Thank you all for coming out today. I'm going to try to talk without a mic. Is that okay in the back? You can hear me all right? Good. Okay. So we are facing an interesting and changing situation with regard to the aging brain. Our population in the United States in general is getting older. So the baby boomer generation is coming of age. There aren't so many young people around to fill the spaces anymore. This is a particularly important issue in Iowa. People may not be aware of this, but Iowa has one of the oldest populations in the nation. Part of that is because we're a healthy state. People live a long time. People tend to stay in place here, so people are often born in Iowa and they live here throughout their lives. So the idea that we are facing a real tidal wave of aging brains is hitting pretty hard right now. We're not entirely sure how to deal with this as a society. One of the big places where we have to look hard at this is in the workplace. And I'm sure all of you are aware, whether you're involved in business, whether you're a customer of businesses, the workforce is getting older. And that raises a lot of concerns. It raises concerns among workers. It raises concerns among employers. What does it mean? There are many stereotypes of the older worker. Old people don't think very well. They're not going to be as reliable. And what I want to do today is just sort of lay down some of the facts of the situation. I'm not claiming to have all the answers by any means. But what I want to do is talk a bit about the biology of the brain, what happens to the human brain as it ages, how that affects our thinking abilities, and finally bring that to bear on the workplace. So we're going to face some unpleasant facts as we go through this, so you just bear with me on this. I guess all I can say is we're all in this together, okay? All body systems age. Everybody knows that, okay? It doesn't matter if we're talking about the digestive system or the skin or your eyes. I think everybody that's over age 30 knows body systems age. They age with different trajectories. Some consequences of the body aging are pretty easy to measure. So we can take physical measures, so you can measure things like muscle mass, bone density scans, where you can get a clear physical indication of aging. You can take functional measures. So you can measure strength. How much can somebody lift? measure visual acuity. So these are the functions of these body systems. You can even go into the workplace and measure things like number of sick days. But when it comes to the aging of the mind and the brain, it gets very difficult. We don't have a direct pipeline to the brain. The brain's encased in this hard skull. You can't see my brain, I can't see yours. It's very difficult to know what's going on in there. We're also different to start with. How do we take into account just the normal human variability in this? So there are a lot of major challenges when it comes to thinking about the implications of an aging mind in the workplace. So just a little primer on the brain here. I know most of you probably don't spend your days thinking about this. It's a pretty fascinating organ. I mean, what we're going to focus on here is not aging in general, but aging of one particular organ, aging of the brain. It's not much. Your brain only weighs about 3 pounds, and most of that is just water weight, okay? Yet that brain is the foundation for everything that we do. It's for our thoughts, our creativity, our loves, our emotions, our sense of self. It's all up here in the brain. That little 3-pound mass of mostly water is doing all of this. It's far and away the most complicated organ in the body, and we don't know much about it. So I'm up here talking about the stuff we do know. If we put this in perspective, we know about this much about how the brain works. We don't know this much. If I come back here in 10 or 15 years, this will be a different talk. We're learning a lot about this as we go. The basic working unit of the brain is the neuron. And it's a cartoon of the neuron here. Is this okay if I wander over here? I don't want to throw off your video. Okay. So we have a cartoon of a brain cell, of a neuron here. You have about 100 billion of these in your head, okay? Basic structure, you have a cell body, has these little branches, one particularly long branch that comes off. This is the axon. If you get down to the end of this axon, it's blown up in this box. This is where neuron number 1 comes down and talks to neuron number 2. Every one of these 100 billion cells can have as many as 7,000 synapses. This is a synapse. It's a connection with other neurons. You can do the math. You can get an idea of the complexity of this wiring diagram. This is what allows us to be the complicated creatures that we are. Everything that's happening in our brain operates on a couple of very simple principles. There's an electrical charge that will travel down this axon, down this long branch. It's wrapped in fatty tissue, which serves much like an insulator, not too different from the insulation on cords that we might see around here. Once that electrical charge gets down and is ready to communicate with the next neuron, it becomes a chemical process. So you have these two things, an electrical charge and a chemical release. It releases neurotransmitters to the next neuron. That's, in a very simplified form, what all of our thoughts, our movement, our perception is doing. If you think about what's happening right now as you look at this screen, light's reflecting off this screen, it enters your eye. At the back of your eyeball, it's stimulating a neuron. That's setting a chain of events in emotion that sends that information to the back of your head where you have visual cortex. It's interpreting this image, things like the color, the shape, the movement, say, of my hand is interpreted in another area. But everything we're doing is based on these pretty basic principles. All right, so here's a basic outline for how I want to approach this issue. Okay, that's sort of your little primer on the brain because I'm going to keep coming back to the brain here. 3 basic issues we're going to look at, and it's traced out here. We're kind of trying to fill in the arrows in the top part here. So how does the brain physically change as a result of aging? That's sort of the ugly part we have to get through. And we want to talk about how those physical changes in the brain affect cognition. And by cognition, I mean just thinking abilities. Cognition encompasses memory and problem solving, creativity. It even includes things like emotion, which is very tied up in decision making. And then lastly, we want to put this together, how aging affects the brain, how that affects cognition, and then what does this mean for work, for job performance. So let's start at the beginning here. How does the brain physically change as a result of aging? All right, here's the warning. This is going to get ugly. All right. So I'm going to say a bunch of kind of scary things here. But keep in mind, there's a next chapter. So don't walk out in tears before you let me get to the next part. Okay, the aging brain. One, it just flat out shrinks. It gets smaller, and I'll show you a picture of this in a bit. It's reduced weight and volume. We lose gray matter. Gray matter are the neurons, the cell bodies. Some of these disappear. We lose synapses, those connections of one neuron to the next. We lose white matter. That's the sort of fatty insulating tissue on the axons. The neurotransmitter activity in the brain goes down. These are the chemical messengers that one neuron uses to talk to the next. Cerebral blood flow goes down. Brain is hugely dependent on a good supply of blood. This decreases over time. We will develop microvascular damage. So if you think about how the blood vessels are in the brain, think of like a tree branch. So you have the big branch, and that splits into smaller branches and into smaller and smaller. And finally, you get down to the tiniest twigs, which in the brain are microscopic. But it's pretty much guaranteed that all of us, if we live long enough, which is 65, 70, we will have microvascular damage in the brain. Those tiniest blood vessels are the most vulnerable. There's change in the activation of functional networks, and I'll show you what I mean by that in a bit. But a functional network might be something like the visual network. So how that network actually operates will change over time. Our ability to repair DNA damage declines over time in the brain. And pretty much all of us, if we live long enough, will develop some degree of Alzheimer's pathology. That doesn't mean we're all going to get Alzheimer's disease, but if you look at the brain of pretty much anybody in their 80s under a microscope, you are going to see elements of Alzheimer's type pathology. Some people would say we will all get it if we live long enough. The fact is, most of us will die, our heart gives out, or something else before we reach that point. So here we can see some of the shrinkage. So what you're looking at here, top row, these are the columns are just different imaging techniques. So let's focus on this column here. Early late echo is just it's an MRI sequence. It's one of the ways we use the MR machine to look at the human brain. This is a 21-year-old brain, a 53-year-old brain, and a 71-year-old brain. This is a cross section, so it's like a section like this through the brain, and you're looking down at it from up above. So if we look at this youngster's brain, these are ventricles. These are the normal fluid-filled spaces in the brain. The brain has a lot of sort of hills and valleys and indentations, and what you see here is the valleys are pretty tight and small. There's not a lot of space there. We get up to the 53-year-old brain, and if we just say, look at these ventricles here, and you compare it to here, there's a change, right? These ventricles have gotten bigger. It's not that the ventricles have grown, it's that the brain tissue is smaller, and the ventricles just take up that space. And we get down here to a 71-year-old, and you can see the process continues. The valleys in here are getting bigger. The hills are getting smaller. So it's just a way of imaging that type of brain shrinkage. One thing to keep in mind is that there's a lot of variability between people. So this isn't going to characterize necessarily your trajectory of your brain, but these are fairly representative individuals. If we look at the level of a single neuron, you can compare here a very bright, bushy, healthy, robust neuron. It has lots of these dendrites, lots of these branches, and each of these will talk to other neurons. As we get into an older neuron, there's less of that. So even if the neuron itself doesn't die, it's still present, it doesn't have as many connections. It's not as big and bushy. Now here's a brain that's been dissected out, and what I want to see here is the white matter pathways. So Keep in mind the white matter is sort of wrapping around an axon, serving as much like an insulator on a cord. It has other functions as well, but that's a primary function. Here, it's as if you're laying on the floor and looking up at this individual's brain, and it's been dissected away to reveal white matter pathways. This happens to be the visual pathway. So the person's eyes are up here. It's going to send messages back to a structure we can't see very well here, and then on back toward the very back of the brain, which is down at the bottom. Point is just that you can see these white matter pathways. These are sort of highways of information. It's the way one part of the brain talks to another part of the brain. Now, we can see what happens to these white matter pathways as a result of aging. We have here a 26-year-old and over there a 73-year-old. And the part of the brain that we're looking at here, it's oriented like my head is. This is the corpus callosum, this white band, which is sort of the major connector between left and right hemispheres. What you're looking at here in the red and green, which is what I want you to focus on, are the white matter output and input to the corpus callosum. And just compare that red to this red, that green to this green. This is an example of white matter aging. These pathways are still present in the older brain. They don't look terribly different. They're still trying to perform the same functions. There's just not as much there. Okay? It's harder for that information to move through that area. A consequence of this is often that information might move slower. It's one of the most common complaints as people age. They say, well, I'll remember his name if you give me enough time, right? It slows things down. White matter kind of helps speed things along. This is a cartoon of the distribution of Alzheimer's pathology. So I think most of you probably are familiar with Alzheimer's disease. It's far and away the most common cause of dementia or cognitive loss with aging. Alzheimer's is very, very prevalent. It affects most families in one way or another. We don't understand it very well. We don't have a cure for it. And it has a huge overlap with the normal aging process. Now, down here, you're looking at Alzheimer's pathology under a microscope. And I won't go into a lot of detail about this, but this is a neuritic plaque. It's basically an accumulation of cellular debris that happens in Alzheimer's disease. This is a neurofibrillary tangle. Again, you're looking under a microscope here at an autopsied brain. The neurofibrillary tangles are tangles of protein that happen within a neuron. It's taking sort of the scaffolding, the structure of that neuron. Think of like the columns holding up this ceiling here. And they get distorted and bent, and they don't work right. And in the end, it leaves that neuron dysfunctional. It can't do its job. If we look at where these neurofibrillary tangles, NFT, accumulate, the color code here is that the warmer colors, as we get into the yellows and reds, is a greater concentration of this Alzheimer's pathology. And I want you to focus on this view. Here's a lateral view of the brain. These brains are facing toward me. What you have here is that if the brain was sliced right down the middle, so you're looking at the inner surface of the right hemisphere. Here's the corpus callosum, so the nose would be about here, ear is sitting about here. What you see in this area, which is on the inner part of the temporal lobe here, is a very heavy concentration of these neurofibrillary tangles. These are the Alzheimer's tangles that make that structure not work. What does this part of our brain do? This is a critical memory structure. If you right now think back to what you had for breakfast this morning, or who was the last person you talked to on the phone last night, you're running through that area. That part of the brain is absolutely necessary. So in Alzheimer's, we have this gradual accumulation of pathology in this area. It renders that part of the brain dysfunctional, brings down memory gradually and slowly. Everybody gets a little bit of this, as I said. The difference between normal aging and Alzheimer's, it's mostly a matter of count. If we want to go in and make a firm diagnosis of Alzheimer's disease, it's at an autopsy, and it's basically going in and counting how many of these. If you don't have enough, if you don't reach that threshold, we call it normal aging. Somebody has enough of these, you cross the threshold, we call it Alzheimer's disease. Vascular changes. Okay, so these are changes in the blood supply to the brain. I talked about the tree branch analogy, and you can see a picture of that there. It's basically two things that happen. This is a plumbing system. Okay, the brain is dependent on this continuous supply of oxygenated blood. So if I cut off the blood supply to my hand for a while, if I put a tourniquet around here, my hand will go numb, but then I take it off and my hand comes back and it's good. Brain's not like that. Okay, you cut off the blood supply to the brain and those neurons die. That tissue is dead and gone. And the most common way of thinking about this, most people are familiar with a stroke. A stroke is when either, there are two kinds. There's ischemic, which is basically the pipes plugging up. So there's a buildup of material in the pipe, or something could be released from another part of the body and it plugs up that pipe. Blood doesn't flow anymore. Or hemorrhagic, the pipes burst. Okay. Here you can see a stroke. Here you're again looking at a cross section of the brain looking down, and you have this area of damage. On the outer surface it doesn't look like a lot, but you get inside and you can see the blood supply to that area was cut off. That part of the brain is just gone. I'm not sure if you can see this from the back, but here is an example of sort of the microvascular changes that could happen. So instead of having a great big blood vessel causing a large area of damage, you have lots of little ditzels in there, tiny areas that have been damaged due to vascular changes. And again, the unfortunate thing is pretty much everybody gets a little bit of this. Now this is important. There's no clear line of demarcation between a normal elderly brain and a brain with age-related neurologic disease. And this is it's a key point. For many of these things, if we think about Alzheimer's disease or vascular disease, or we can go on down the list, there's a prodromal stage. In Alzheimer's disease, it could very easily be brewing in somebody's head for 2 decades before we're able to discover it at a clinical level. Again, this is a thresholding type of thing. Same way with vascular disease, can be brewing for a long time. Parkinson's disease, when there's critical structures that are affected in Parkinson's disease, those structures have to lose almost 60% of their neurons before we start seeing the physical signs that we can detect in the clinic, the tremor, the stoop posture, and the other things. So the point here is that there could be a lot of things going on in the brain. Our brain can absorb and compensate for a lot of damage, a lot of these changes. And a lot of these changes are going to happen to all of us. The point is you hit a threshold where the brain can no longer compensate. And that's when things start to become clinically evident. You start to forget things that you really should remember. Movement might change, perception might change, thinking abilities go downhill. All right, the silver lining. I've just sort of bombarded you with lots of nasty stuff about what's going on in all of our heads, but it's not all bad. In fact, in the end, I'd like to think this is kind of an optimistic talk, but you have to get through that early, ugly part to get there. All right. This is one of the really great things that we're learning about the brain, and that is the brain is plastic. And I don't mean it's made out of plastic, but when we talk about plasticity, sometimes we refer to neuroplasticity. It means that the brain can change and adapt. Individual neurons can change and adapt. In fact, your brain is undergoing plastic changes as we sit here. And I'll say a little more about that. Let's just say, and I'm going to hope this is true, I hope everybody walks out of here learning at least one little thing, okay? Maybe all you learned is the name of the person sitting next to you. Maybe you learned some fact about how the brain works, okay? What does that mean, that you learned something? You're going to walk out of this room with something in your head that was not in here when you walked in. That's learning, okay? What happened? There has to be a physical correlate of that learning. And I'll show you kind of the key thing that underlies this learning. And we're going to use a monkey experiment to kind of demonstrate this. So here's our monkey, and he's just sitting here and he's thinking monkey thoughts, dreaming about bananas or whatever monkeys think about. And what we've done is put 2 microelectrodes in this monkey's head. And we've put one in an area back in visual cortex, in the very back of the brain, that codes for color. And in this case, we put it in an area that codes for red. Okay, you have the same type of area in your brain. We put another one in a very distant area up in the front of the brain in a reward center. And we put this in an area that responds to things this monkey really likes, including the taste of his favorite juices. Now, we're recording the electrical firing from these neurons, and they're firing kind of randomly. That's what neurons tend to do when they're not being real activated. And there's no synchronization. There's no reason red is hooked up with this reward center. Then we train our monkey friend. We put him in front of a screen, and we give him a task. And he learns every time he pushes the red button, he gets a shot of his favorite juice, and he really likes this juice. As we continue recording from these neurons, look what happens. Their firing becomes synchronized. When he sees red, he thinks good things, okay? Now, when you think about your spouse and you think happy, warm thoughts, this is exactly, or maybe you think nasty thoughts, but this is exactly the type of thing that happens. There's a pairing of 2 very different things. Then we come back later, he's no longer sitting in front of the screen, he's just sitting there thinking about it, but learning has taken place. There's a synchronization of those firing patterns. So when you learn something new, you learn a new name. Let's say this is the person sitting next to you, and this is the name John, okay? You didn't know his name was John when you walked in. You know it when you leave. There's been a synchronization of firing patterns. It's how most new learning takes place. This is a plastic change, and the old brain is capable of doing this. Old dogs can learn new tricks, okay? We used to think that it just went downhill, that this was just, it got harder and harder, and it does get more difficult. There's no doubt that a 20-year-old can pick up new information, can synchronize those firing patterns easier than a 70-year-old can do it. But it doesn't disappear. That ability is retained into old age. So, we've been talking about these physical changes in the brain with aging. Let's take it to the next step. So we've talked about what happens in the brain, to the neurons, to the white matter, the vascular. But what does that really mean for cognition, for our thinking abilities? So just as I said, there's no clear line of demarcation between a brain with pathology and a normal aging brain. The same is true with regard to cognition, okay? And what we can see here is sort of a spectrum of normal thinking ability, the thinking abilities which are quite impaired in Alzheimer's, and then there's a major transition stage we've called mild cognitive impairment. Again, the point is there's no clear, hard, and fast line. This is not a black and white issue. The thing that's important about this, the relationship between the pathology, what we see, so the physical changes and the cognitive performance, is not a one-to-one relationship. If we look at a group of people, we'll very clearly say these brains with more pathology are thinking less well. But if you take any one individual, I can give you 2 examples. We can take an individual with just great, sharp cognition, 90-year-old man, say he dies of a heart attack. And he was sharp as a tack. We look at his brain, and it's full of Alzheimer's pathology. How did that happen? He ought to have been demented, but he wasn't. We're not sure why. You can see the other side of this. You can see somebody who's shown clear cognitive decline, is not thinking well, not doing well cognitively in old age. Their brain looks pretty fat and happy. Okay, so it's not this clear one-to-one correlation. There's a general correlation, but the specifics are much looser than that, and we don't understand it very well. So what are the changes that happen in normal aging? There are some changes. They tend to be mild. That's the good news. So there tends to be a mild decrease in recent memory and working memory. Working memory is sort of holding things online. So an example would be looking up a phone number in a telephone book and remembering those 7 digits in the time it takes you to type it in on the phone. That's working memory. You only have to hold it there for 60 seconds or so. Recent memory is things a bit longer than that. What did you do yesterday? What did you do last week? So these things do decline a little bit in normal aging. There's some slowing. Things take a little bit longer. And I think we can probably all relate to that a little bit. Novel problem solving. So if you face somebody with some type of problem they've never seen before in their life, generally speaking, the younger person is going to be able to handle that better than an older person. Older people tend to be really good with things that they have done repeatedly, okay? But when they're faced with something new and out of the ordinary, it can be more difficult. Word finding problems. So everybody has word finding problems. You want to think of something. People's names are the most obvious, but it might be, what's the name of this thing? You know perfectly well what it is, but the name is escaping you. These word finding problems become a little more pronounced as we age. Good news is there's a preserved knowledge base. So a person's wisdom tends not to be lost. In fact, it often continues to increase forever. There is increased vulnerability. So everybody knows that, let's just say you have a head cold, right? It's hard to think clear when you have a head cold. You had a bad night of sleep for whatever reason. It's hard to be sharp the next day. All of these effects are basically amplified in an older brain, so that an illness, a head cold, fatigue, these things are going to have a greater impact on thinking abilities. Drugs are a huge issue. Most older people are on multiple medications. They often interact in ways that are not well predicted. And whereas a 30-year-old might react in a certain way to a given painkiller, a 70-year-old could have a very exaggerated reaction to that in terms of their thinking ability. One of the neat things about aging has to do with emotions, and that is, as we age, we tend not to be not so reactive. Young people are very reactive. Something happens and they get all worked up about it. Older folks tend to take things a little more in stride. There's less reactivity and less negativity. Now, that doesn't necessarily apply to every one of us, but again, in general, there are positive changes in emotions as we age. So, we've talked about these structural changes in the brain. They are correlated with cognitive abilities. So we talked about this area here on the inner surface of the temporal lobe. This is the area that's hit hard in Alzheimer's disease. This is an area that we know is responsible for memory. As we look at this area gradually shrink over time, we'll see a decrease in recent memory abilities. Okay? So there's a definite relationship between structure, the things that we can see, and the function, the things that our brain does. But it is, again, it's not this tight one-to-one relationship. Now let's think about activation. So one of the things that you've probably read about is called functional MRI. Functional MRI has been in the news a lot for the last decade or so. And what we do with functional MRI is we take standard MRI as magnetic resonance imaging. So it's based on the fact that all the tissues in our brain have different magnetic properties. So the scanner could look at my hand and it can tell the difference between bone and skin and muscle and fat, and it lays it out in a way that we can visualize it. With functional MRI, what we do is we put the person's head in the scanner, the person's laying there, and we have them do something. So rather than just laying there and taking a picture of the structure of the brain, we're looking at patterns of activation. What parts of the brain are active, metabolically active, while they're doing a task? So maybe it's a memory task or a language task. When we compare older and younger people in an fMRI scanner, there are two things that we see pretty reliably. The first one is underactivation. This seems just sort of like the normal thing we would predict if somebody's not doing as well. This is a word generation task. So let's say I tell you, tell me all the words that you can think of that start with the letter L. Go. And we start a stopwatch. So You're thinking of all these words. This part of your brain, left frontal lobe here, is going to be very active. It's going to be firing up, generating these words. In older people, we see less activation, and they tend to do less well on the task. Seems pretty straightforward, as we would anticipate. It gets more interesting, the second pattern that reliably appears, and that's overactivation. So doing the same task, many older people are going to activate areas that are not active in the younger folks. And these are often areas in the frontal lobes, areas that are involved in strategy. We think of this as probably a compensatory activation. It's interesting that when we see more of this, the people tend to do much like the young people. So a different pattern of activation using additional brain circuitry to accomplish the same task. This is a great example of the plasticity that we're talking about, the ability of the brain to rewire itself to use other resources to get the same job done. So this is kind of neat. There's good and there's bad to this, right? So this is probably the most important slide that I have here. So if you take out one fact, drill this one in. The biggest thing that we see with aging is increased variability between people. Okay, this is really important. The within age group variability, so the variability within 10 80-year-olds is going to be greater than the difference between those 80-year-olds and some 60-year-olds. All right? Take any task. Let's just say a list learning task. I'm going to give a list of 10 words and I want you to remember it. There's a certain amount of variability in a group of 25-year-olds. Okay, there's this much variability. They're all going to remember 6 to 10 words. We go up to a bunch of 80-year-olds, we get this much variability. Some of them are going to do really, really well, as good as the youngsters, but not all of them. Okay, increased variability with aging is the most important thing that we have to deal with. There are many things that affect this aging process, the individual differences. The way this slide is arranged, this is sort of the bad corner, that's the good corner up there, okay? And what makes the difference? It's no one factor, okay? It's a constellation of things working together. And again, keep in mind, there's a whole lot we don't know about this at this point. First of all, we all have certain genetic risk factors, okay? So genes will set things in motion. Best thing you can have going for you is having parents who lived to an old age and were sharp, okay? There are some genes that are protective, there are some genes that are risk factor genes. But in the end, genetic factors, they carry weight, but it's certainly not the whole story. Very, very important is the vascular system. Okay, we talked about those microvascular changes. We talk about the pipes plugging up, the pipes bursting. Probably the biggest theme that come out of neuroscience in the last decade or so is all these things that we've known are good for our heart for decades, they're good for our brain. Exercise at the top of the list. You have to get exercise. Things like diabetes, hypertension, high cholesterol, these are all tough on the brain. They affect that vascular system. Anything you can do to keep that cardiovascular, cerebrovascular system healthy, it's where you should be investing your energy. Go for a walk. It's the best thing you can do for yourself. We talk about these physical changes, the atrophy or shrinkage, the white matter damage, changes in neurotransmitters. The good side is our ability to compensate, that functional plasticity. One of the things we talked about on the drive over here today was television, okay? The brain likes a challenge, okay? The brain does not like to sit and be coddled and do nothing. Turn off the TV, okay? There is a use it or lose it phenomenon. When you sit there and you watch TV, your brain is not being challenged. Your brain is basically being fed brain candy. Now, everybody watches some TV. I watch TV. Just don't watch too much. You need to get off your butt and go do things. Read a book, exercise, pick up a hobby. Cognitive training, actively embracing life is critical. If you take two guys and let's say they both had an event, maybe it's a stroke, this guy sits in his lazy boy and watches TV for the next 5 years. This guy gets back on his horse. He's out doing things, he's volunteering, he's involved with people, he's challenging his brain. In 5 years, these guys are going to be just in vastly different places. Okay? This is hugely important. You've got to use it. And that's both physical activity and mental activity. Keeping a good attitude goes a long way. Having a positive bias. Depression takes a toll on the brain. Stress takes a toll on the brain. We all are faced with stress, right? It's part of normal life. It's not that you avoid all stress, but when the stress level starts getting too high, it has an actual toxic effect on neurons. You can see it killing brain cells. So having an active approach to stress management, whether that's something like meditation, music, there's no one formula that's absolutely right for everyone. But the fact is, you want to try to keep a good attitude. Maybe it's going to see a therapist, getting things in a little different perspective. A bad attitude, being very stressed out, being depressed, takes a physical toll on the aging brain. Okay, so this is what we've been, our summary slide here. We're getting down toward the end. Let's just sort of review what we've been doing here. And I'm leaving some time at the end here that we can take questions. So what we've seen so far, the brain physically ages in several different ways. Most of these physical changes in the brain, they're on a continuum with the type of changes that we see in dementia. Okay? There are relationships between these changes in the brain and cognitive decline. But these linkages are complex. We don't understand them very well yet. It's not a simple one-to-one relationship. Number 3 here, there are changes that happen with normal aging. They're generally mild, but importantly, there's a great deal of variability between people. Those within age group cognitive differences are really bigger than the differences between two different age groups. So what does this mean for the workplace? Well, there's no doubt that the probability of a cognitive weakness or a cognitive impairment goes up as workers age. And this, of course, could be relevant to job performance. However, that doesn't tell you anything about Joe Smith, your 75-year-old employee, okay? Because any individual worker may or may not experience these changes. You can't say because on average the group moves in this direction that applies to any one individual, because we have this great increased variability between people. So we look at this cognition to performance basis. This is largely what I just said here. There's a lot of variability. The link between cognition, now here's a new point, this link between the cognition even and job performance is moderated by a lot of different factors. People can develop compensatory strategies. Maybe it's as simple as writing more things down. An older worker is probably more likely to have a note card and a pen in his pocket to make some notes of what that order might be. Computer devices have unlimited memory. They make great compensatory devices. People develop skills. They develop tricks. Simply having your workplace more organized can decrease the load on memory and allow somebody to perform well despite the fact their memory is not so good. There are also differences between jobs. There's not a lot of data out here yet, but there are indications that very highly skilled workers tend to be more resilient. They tend to experience less in terms of aging decrement. Again, you have to be careful thinking about an individual worker, but these are general trends. So, the wrong question is this person too old for the job? That just doesn't apply. There's no age at which you say, yes, this person is absolutely too old. There might be a law, there might be a legal requirement, but it's a line in the sand. It's an arbitrary line in the sand. Okay? The question really is, does this individual have the abilities to perform this specific job? What do we do about this? Well, one of the things that we see at the hospital dealing with older folks is there's clearly a natural selection process. People often know when it's time to retire. They'll take themselves out of the workforce. Oftentimes there may be some subtle pressures from coworkers saying, hey, you know, you're not pulling your weight anymore. But there is a natural selection process. It's actually fairly rare that we have to get in and sort of intervene, but it does happen where a person may not be aware that they've experienced cognitive decline. But this process does take place. Secondly, we can measure these individual differences. So if a job has particular demands, if this guy is, say, in running a nuclear power plant, and we say he has to have the ability to solve this dilemma in, you know, this many seconds, we can test for that. We can evaluate these abilities. And rather than saying, well, at age 65, you're just done because we've decided 65 is when you're done, what we need is fair and valid evaluations. A lot of these evaluations don't exist or are not being implemented, but it's clearly a direction that we need to be taking things. So, as we go forward, there are both positive and negative modifiers that influence the course of aging. Okay? Positive things are things like exercise and keeping healthy and keeping a good attitude. Negative things are things like not being active, sitting in the chair too much, depression, over-medication. This has implications both for each of us as individuals and for how society thinks about how we approach aging, because this is a hugely expensive problem for us as a society. The second point here is you know, really the optimistic point here is the more we study this, the more we see that the aging brain has capacity for functional reorganization, getting different parts of the brain to do different things, that there's this plasticity, and that there are things that we can do, potential interventions that can help. Simply getting somebody on an exercise program. You're never too old to start. Getting somebody off the couch, out of the lazy boy, and doing something that's actively challenging their brain. These things are going to have implications for that individual. If these things are implemented on a societal level, it's going to have good implications for the entire workforce, our economy, our general well-being. So, with that, I will stop and I would be happy to take questions. Yep.
You've not talked much about food intake, how that affects the brain. Would you offer a few comments on the extent to which diet can affect operation of the brain?
It's a great question. I wrote over here with a nutritionist who knows a lot more about this than I do, so I'm going to be really careful here about what I say, and maybe Linda needs to weigh in. At this point, in my opinion, and I'm not a nutritionist, but there's no evidence for brain foods. Okay, so I can't say, you know, if you eat your lima beans, it's going to improve your brain function. There's a lot of evidence that having a healthy diet is really important. And there are a couple things with that. Caloric restriction, in animal models, caloric restriction, keeping an animal on a very low-calorie diet, is one of the best ways of increasing longevity and function. I like to eat. I'm not a big fan of low calories myself, but it is one thing that can be done. There is good evidence that keeping your body healthy, eating your vegetables, not eating too much fat or sugar or alcohol is very good for the brain. A lot of that might be moderated by the vascular system. It's not entirely clear yet. There's some evidence that what's often called a Mediterranean diet has some benefits. And relative to what most of us in Iowa here eat, that means going a little lighter on the beef, eating more fish, more nuts. Eat your veggies is probably the best thing I can say. So at this point, the main advice is, you know, sort of eat the way you ought to. Eat a good, healthy diet, and you're probably doing about as much as you can do for your brain. And stay tuned, because it's certainly an area of active research. Yeah.
You mentioned that watching TV is a passive activity for your brain. How does that compare to reading?
Okay.
Be a passive or an active?
Yeah, so the question is, I kind of dump on television. I say TV is bad for you, it's a passive activity. He's asking, how does that compare to something like reading? Reading is active. Reading requires you to put things together. You're drawing back on the history, you're putting the pieces there. Your brain's having to do a lot more interpreting when you're reading. So I advocate reading. Okay, reading is generally a good thing.
Are there some computer games that have the design of engaging the brain more effectively?
Right. So the question is, are there computer games that are good for engaging the brain? There are. What's lacking is any evidence that you doing computer games is going to help you any more than him reading a good book. Okay? The evidence is very clear that keeping your brain active is good. Now, if you're keeping your brain active because you are in a card club and you're playing bridge on a regular basis, or maybe it's just a coffee club and you're engaging in a lot of conversation and such, it's all basically good. Your brain likes a challenge. So, if you're the kind of person who likes doing math puzzles or crossword puzzles, go for it, do it. But if you're not, there's no reason to torture yourself with this if you can get your cognitive stimulation in some other manner. Volunteering, getting out and being with people. It's the challenge that matters. And the same goes for exercise. You know, it's not everybody who wants to go jogging. You don't have to go jogging. You know, maybe you want to do aerobics in the pool. Maybe it's going for a walk. Maybe it's riding a bicycle. I don't care what you do. There's no evidence that biking is better than swimming versus jogging. What matters is all of those are a whole lot better than sitting on the couch. Yep.
Are there any noticeable changes between ethnic populations and how the brain ages?
Ethnic population and brain changes. They're tantalizing. There are some populations where we tend to see very little dementia, and those are interesting groups. These tend to be remote populations. They tend to have diets that are heavy on seafood and nuts, and this is sort of an impetus for this Mediterranean diet. Within the United States, we deal with some major risk factors. For example, African Americans are at greater risk for cardiovascular problems, diabetes. All of these have downstream implications for the brain. But beyond that, there's not a lot. Anybody from any racial, ethnic group, men, women, any socioeconomic status, everybody's vulnerable to these same factors. Everybody benefits from the same factors. Yep.
Your comment on the monkey slide
Yeah.
seemed to me was an example of neural feedback.
Mhm.
Would you care to comment about the state of the art of neural feedback as a therapeutic technique?
Sure. Different people will interpret that in different ways. So often if somebody goes in for neurofeedback, say in a rehab program, what they're getting is some type of visual feedback of what their brain activity is doing. So a very common one is stress management. So I come in and I'm a uptight guy, and my goal is to calm down, to relax. And how do I know if I'm relaxing? We could put EEG leads measuring electrical activity on my head, and that could be put into a visual screen. And that screen could say, okay, let's say it's a picture of a beach. And that picture becomes clearer, more crisp, if I can increase activity in this relaxing part of my brain. It's a way of giving feedback to people. And it can be helpful, okay? There's very little evidence that it's any better than, say, learning that same technique without that type of sort of technological feedback. It has potential. We use it sometimes. It's not a panacea, but it doesn't hurt. Yep.
Can you help me understand when I hear somebody has dementia but they don't have Alzheimer's, or vice versa? What
Yeah.
is the difference?
Right, so the question is, what's the difference between dementia and Alzheimer's? Dementia is the umbrella term. So all dementia means is a decline in cognitive abilities. Usually it refers to a slow, progressive decline. Most commonly it's going to be a gradual worsening of memory and then language and other abilities. Alzheimer's disease is the single most common cause of dementia, but there are literally hundreds of different causes of dementia. Okay? So vascular problems would be another thing. So somebody might, my father had a vascular dementia. He didn't have Alzheimer's disease, but a constellation of tiny strokes caused a vascular dementia. There are dementias associated with Parkinson's disease and on down the list. So Alzheimer's gets the attention because it accounts for more than 50% of the dementias. Nothing else comes close to that. So if you diagnosed everybody with dementia as having Alzheimer's disease, you'd be right more often than you'd be wrong, but you'd still be wrong pretty often.
Or just say about one, if anybody does need to pack up and please take that moment to do so, but we'll keep the questions.
Sure, I won't be offended if people need to leave. I saw a hand in the back there. Differences between males and females. Females get more Alzheimer's disease, but the number one factor behind that is that they tend to live longer than us. Women live longer than men. You go into a nursing home and look around, and what do you see? There are probably 7, 8 women for every guy in that nursing home. So age is the single greatest risk factor for Alzheimer's. If we take that out of the equation, there are very little differences. Women may still have some increased vulnerability. It's been linked to the hormonal system, but it's not huge. So the biggest factor is simply that women live longer than men. They have more opportunity to develop Alzheimer's disease.
Are there any supplements that you would recommend to help with the aging process? I heard things like even vitamin E now or
Right.
I've heard of all kinds of things.
Right.
that help with that.
So the question is, are there supplements that we recommend? Don't hit me again. The short answer is no. So 10 years ago, if somebody was diagnosed with probable Alzheimer's disease, we would put them on an Alzheimer's-related medication, which they're not very good, but they help a little bit, and we would put them on vitamin E. Because there were a couple of studies that showed a slight benefit from vitamin E. That hasn't panned out with subsequent research. These things seem to not make much difference. My big concern with supplements is that they tend to be unregulated. You get a prescription medication, the FDA is looking over that. Even if we think the oversight might not be that good, we pretty much know what's in that pill. You get, Palmetto dust or whatever you want to buy at the nutrition store, you have no idea what's in there. We see a lot more problems come from these things than we see good. If you're eating your veggies, a good healthy diet, I say stay away from the supplements. It's my opinion, but it's out there. Yeah.
You talked about Alzheimer's as being a natural function of aging. Do you expect any treatments or drugs to deal with Alzheimer's in the next 10 years?
Oh, that's a hard question. He's asking if there are drugs on the horizon for Alzheimer's. There are certainly things being investigated, and it can turn a corner at any point. The difficult thing right now is we don't understand the disease that well to be able to pinpoint what we ought to be looking at for treatment. A lot of the leading theories of what we thought were going to be effective treatments are not panning out. So it comes back to this sort of fundamental issue that we don't understand it really well enough. So any approach to treatment right now, it's not a shot in the dark, but it's an educated long shot. So is that going to change in 10 years? I have no way of knowing. I mean, there are literally thousands of laboratories around the world looking at this problem, and everything from cellular models to mouse models to human trials. And I remain hopeful that something's going to come around. But do I see something percolating, say, down in the mouse research right now that I'm real excited about, or the scientific community is real excited about? No.
Are there
Right. Yeah, it's a great question. Are there tests for these things? Yes, there are. And I think if anybody feels like they are experiencing cognitive decline, or if you feel like a loved one is experiencing cognitive decline, you definitely want to get in and have that looked at. A standard evaluation would include things like neuropsychological testing. So this is testing of remembering a list of words, solving a puzzle, generating words as fast as you can. Mental tests, that's a key part of it. An MRI brain scan, similar to what we looked at here, would be part of it. The other thing that would happen is that we would look at a number of laboratory tests, blood tests, because it might be something that's very treatable. Not all cognitive decline is Alzheimer's disease. It could be, say, an interaction of medications a person is taking. We've seen people develop, an 80-year-old woman developed severe confusion from a urinary tract infection. Okay? There can be just literally hundreds of different things that can cause dementia. Even though in the end Alzheimer's carries a lot of the weight, many of these other things could be treatable. Maybe it's a little tumor that could simply be plucked out and the person would be good. So yes, there are tests. You don't want to take online tests. You don't want to self-diagnose. You want to go to a dementia clinic. Yep.
What is the neurologist's view of psychiatry, especially psychotropic therapy, SSRIs? How do you view that?
Well, in a lot of places now, you have a combined department of neurology and psychiatry. I mean, what's a psychiatric disease? A psychiatric disease is a brain disease. It's just a brain disease we don't really understand. So neurology, we deal with the simple stuff because we deal with a hole in the head. We can see that, right? We can see shrinkage. But what is schizophrenia in the brain? What is depression? We really don't know very well what these things are. But I guess, my view is there is no clear line of demarcation. I think one of the things that is troubling about modern psychiatry is an over-reliance on medication. So as I talked about here, there are a number of things you can do behaviorally. Simply getting out, going for a walk, getting outside, socializing with people. I would like it that nobody gets put on an SSRI unless they're already on a guaranteed exercise program and they are out socializing and their sleep patterns are cleaned up. And if we can do all that and their mood is still low, then let's go to an SSRI. But in many cases, people are on way too many medications. And
follow-up
yeah.
question, do you see any brain structure changes from cognitive therapy? Let me just stop there.
Yeah, so are there changes with cognitive therapy? Yeah. This isn't my own research, but it's out there in the literature. You can see reorganization of functional networks with fMRI based on cognitive therapy. And in fact, effectiveness for depression, I might be preaching to the choir here, but psychotherapy and SSRIs are right here. And one doesn't carry any side effects.
I heard you say plaques or an accumulation of debris within the brain, something that happens. Is that all related to vascular or heart plaque?
No, different process. Different process. The neuritic plaques in the brain are really cellular debris. So it's bits and pieces of neurons and such that are breaking off as opposed to the plaque that builds up in the blood vessels. There is a vascular component to Alzheimer's disease. The other thing that's important to point out is when it comes to autopsy on somebody who's had dementia, in most cases we find more than one process. So even though somebody carries a primary diagnosis of Alzheimer's disease, we'll also see vascular changes there. Even though somebody carries a primary diagnosis of vascular dementia, we'll probably see some Alzheimer's things. So having one does not prevent one from having the other. They often work in concert. But the use of the word plaque there is two totally different things. Oh, sorry, I didn't mean to, I'm neglecting this corner. Sorry. Yeah.
Before my 94-year-old mother died, she somebody'd come visit her, and the next day I'd say, wasn't it nice that Mary visited you? Mary came and visited me, don't we?
Right.
But she could still sit there and tell you what happened when she was 10 years old and
Yep.
ad nauseum, basically.
Yep. Yeah.
What happened when she was 5 or
Right.
10 up until the end. What's the
Right.
significance?
So that's a good question. So there's a very common pattern. Individual can't remember what happened this morning or what happened yesterday, but they can tell you their third grade teacher's middle name. How does that work? It seems completely wrong. It seems like it ought to be much easier to remember what happened yesterday than what happened back when you're 10 years old. Different brain systems. That is the summary answer. So if we think back to that picture that showed that accumulation of neurofibrillary tangles in this temporal lobe in Alzheimer's disease, new learning, acquisition of new information depends on that. Once you've had that information in your brain for a little while, it gets distributed out into other areas and no longer requires that. So what we can say about your mother's situation based on just that little description is she had something very wrong with that hippocampal system. And much of the rest of her brain out here in association cortices probably was working quite well. That's where those old memories are stored. But getting new memories in there, that pathway had been damaged by something.
I remember reading years ago, maybe this is obsolete because of the progress in the last 10 years, but this person concluded that the human brain was literally the most complex thing in the entire universe. Is that an overstatement?
I don't think so. You know, think about what the human brain has accomplished. You know, it's utterly amazing. I don't know what I would weigh it against. I mean, maybe if we weigh it against the cosmos and everything in outer space, that might be equally complex and equally unknown. But compared to anything, I mean, we right away have to write off man-made items, skyscrapers and jets and rockets, because the human brain created those, right? What in nature is this complex? I don't know. So I think it's a very legitimate statement. It's certainly the most mysterious thing out there.
Young people who are playing football who get concussions, serious concussions, and maybe 3, are they more likely to develop in later life dementia?
Yeah. Right. It's a good question. So do multiple concussions, so a concussion is a mild head injury, mild brain injury, do multiple concussions set the stage for dementia? The short answer is yes. That doesn't mean that everybody who's had a concussion is going to develop dementia, but it is the most established environmental risk factor for developing dementia. If you look at what's happening in the National Football League right now, National Hockey League, you have these players that have been bashing their heads for all these years. Now as they reach middle age, they're developing severe dementias. It's a big unrecognized issue. The part that's a little bit scary now, it's not so much, I'm not all that worried about professional football players. They're grown men, they get nicely reimbursed for the work that they do. But I worry about the kids. We start playing football and hockey and even soccer, heading the ball at a very early age. And those early head injuries might take a bigger toll than later head injuries. But there's no doubt that multiple concussions set the stage for later dementia. It's a risk factor, a major one.
Anything can be done to overcome concussions? I had a kid that played in the NFL, and he's had 3 of them, and it worries the hell out of me. I'll be long gone before he ever has a problem.
There's nothing beyond the same things that I would recommend for you without a concussion. It's living a healthy lifestyle, it's staying active, it's staying out of the recliner. At the time of concussion, and we get back here to thinking about high school sports and such, it's important, the timing of concussions is important. So if you're going to have 2 concussions, it's better to have them spread out in time. So you don't want somebody returning to play shortly after a concussion. And the rules are starting to catch up with that now. But if it's somebody who's had concussions years past and now you're worried about that individual, I've played hockey all my life. I grew up in Minnesota. There was nothing else to do. And in that era, you know, the closest thing I had to a helmet was the stocking cap my mother knit for me. I worry about exactly these same things. I've had concussions. Yes. In fact, I'm on my last concussion limit per my wife and my doctor. One more and I'm done.
Is there any relationship, correlation between seizure disorders and development?
Good question. Between seizure disorders and development of dementia. Nothing really strongly established, no. You know, seizure disorders take a wide range, so they can range from very mild and occasional and well-controlled to very severe. But in terms of having epilepsy or seizures being a frank risk factor, no. The nice thing about seizures is generally they don't have a lasting effect. A seizure comes on. Seizure is just it's a brief interruption of that electrical activity in the brain. It's really, if you think about that first line where I showed the 2 neurons firing in an asynchronous manner, what happens when somebody has a seizure is things become abnormally correlated. They start all firing at the same time. But when that's done, it's not like a stroke that has a lasting impact. It's over, it's done. After 24, 48 hours, the brain is essentially as good as it was before that seizure. Yeah.
As far as keeping the brain busy, my mother likes to do crossword puzzles and that word search puzzle.
Yep. Keep her going. Keep her going. Yeah. Buy her books. Get her that for Christmas. You know, if she likes doing that stuff, doing that every day is great for her.
I know just getting her to get out and go for a walk has been really tough. She just wants to sit on the couch all day.
Yeah, well, you need both of those. You got to impress on her. She has half the equation. If she's challenging her brain thinking-wise, that's great. But she needs the body part to go with it. Push it. Yeah.
I once heard Alzheimer's being referred to as diabetes 3. Does Alzheimer's have anything to do with sugar or insulin resistance?
Well, diabetes is a risk factor for developing dementia. Diabetes is a risk factor for vascular changes. They're different diseases. The sugar metabolism doesn't play a particular role in Alzheimer's disease, but diabetes is a risk factor for dementia.
So is insulin resistance in diabetes?
It sets the stage for dementia. Yeah, it is. It's a risk factor. Yeah.
You mentioned testing in the workplace. Are there accepted tests that workplaces use? And it would seem to me that would open up for age discrimination.
Yeah, there are an increasing number of these tests being developed, workplace-specific type tests. So you can think of 2 general types of tests. One is a general function test, so say a memory test. And a simple one would be, you know, how many words can you remember from this list? And that test might be appropriate whether a person is a bus driver or he's, you know, a CEO of a company. They still need a certain amount of memory voltage. Then you can have a test that's very specific to the demands of that job, which tends to be a better predictor. What I'm advocating is increased development of this type of test. It's performance-based, and you're not cut any slack for being old. So you're looking for a level of performance, and you know, you can think of driving as a situation like this. You don't get any, you know, extra credit out there on the road for being old. You still have to stop, start, avoid other people. It's the same type of thing. It's a performance-based measure. And I think that's objective. I think that eliminates the possibilities of age discrimination. Everybody's being held to the same standard. And I think that it's a direction we see things going. We haven't gone real far there, but I'm advocating for that. Yeah.
Was Einstein's brain just about 3 pounds like the rest of it? It was
Yeah.
genius was determined based upon connectivity within the brain. His
Right.
brain was about the same.
Yeah, he did not have an abnormally large brain. He had some unusual structuring in his brain, but to what extent that sort of macroscopic abnormality accounted for his genius is hard to say. Biggest brain ever recorded was from a mentally retarded individual. So size of brain is not that critical.
Were people making their brains available after death for autopsy purposes to speed up research?
Absolutely. Absolutely. Particularly individuals that have neurologic conditions that we don't understand, particularly people that we've been able to study while they're alive. But everything I've talked about here is dependent on that type of research. We learn a certain amount from animal models, but when it comes to thinking abilities, you can only get so much out of a mouse. You really need to study human beings.
Reasons why you're sort of behind the curve, and you just haven't, people have not been willing over the years to allow
Yeah.
their brains to be
Right. My heart is a lot like a pig's heart. So decades of research on pig hearts went a long way toward knowing how to take care of my heart. And certain parts of my brain are very similar to a pig brain or a mouse brain. So if we say look at visual cortex, not a lot of difference. But think about language, okay, a key function. We can't study language in a mouse or a rabbit or even a monkey. We get to higher order things like problem solving and such. You need to study people, and you can only go so far into the human brain.
Okay, I want to thank you all for being here today and welcome you to the next Lunch and Learn, which will be at the end of May. And thank you so much for being here.